Hello and welcome to tonight's calculus video where we'll be starting target 34. I can use substitution to find the antiderivatives, including change of limits and change of variables. What we're going to do in this video is just kind of focus on substitution, what it is and how to recognize it, and why it's important. So first off, we got the generic book Y. Anti-differentiation techniques were historically crucial for applying the results of calculus. All right, now here's the real why. We don't have a lot of backwards anti-differentiation techniques. There's no opposite of the product rule. There's no opposite of the quotient rule. So far, the only other rule we have for a derivative is the chain rule. Well, guess what? This is basically opposite of the chain rule, where you have the derivative of the inside, derivative of the outside, and so on. We're going to start with a little review problem. Evaluate this, pause, do it. Pretty simple. You probably already got it done in your head. What is the antiderivative of this? Well, this would be x cubed over 3, or 1/3 x cubed, plus cosine of x plus c. All right, one thing we want you to pay attention to is the differential here, or the equation in here. This is called the differential. Notice that's the same as, the variable we've got there. That's why we can do it, because the variables match up. Right, so as we go on, let's look and compare antiderivative of f of u with respect to u and antiderivative of f of u with respect to x. We got two functions here. U is x squared and f of u is u cubed. Do this part, pause, and come back. All right, so the antiderivative of f of u with respect to u would be the antiderivative of u cubed du, power up, divide by 4, plus a constant. All right, now write that as a function of x. Now u equals x squared, so we'll substitute x squared in. We got x squared to the 4th is x to the 8th over 4 plus a constant. So the antiderivative of f of u du equals x to the 8th plus 4 over c, plus c. X to the 8th over 4 plus c. All right. Number 3, show that f of u equals x to the 6th. Well, that's pretty simple. You take this, throw that into there, power to a power equals x to the 6th. Find f of u dx. So f of u equals x to the 6th dx equals power up, divide, plus a constant. Are the answers the same? Well, no, they're not. And what makes them different is this differential, this dx or this du. So depending on what we take the antiderivative of, it's going to change our answer. And we kind of use that as we do the chain rule. Pause, try these, unpause, get the answer. All right, so A, the antiderivative of f of x dx would be the antiderivative of x cubed plus 1 dx. All right, the 3 powers up to 4, divide, plus x, plus a constant. All right, let's try B, antiderivative of f of u du. So we want u in place of the x. So that would be u cubed plus 1 du. So that becomes u to the fourth over 4 plus x plus c. And finally, f of u dx. Well, f of u is u cubed plus 1, but we want to do it in terms of x, so we need to put u equals x cubed in there. What we get is f of u in terms of x, we get x squared cubed is x to the 6th plus 1 dx. So you're just paying attention to what letter they want you to take to be in terms of. Our function is f of u, but we want it in terms of x, so we use this formula to get it in terms of x. And then what we get is we power up, divide, plus x plus c. And so we're going to use this substitution to make some of these antiderivatives a bit easier. And to do that, we need to just realize that the differential matters. Read this all, and then we'll kind of get there. In order to do this derivative, we need to make sure we're in the right variable. So we can't do g of u dx. We need to either convert this u to x or find some way to get it to be g of u du. And that's what substitution is all about. We're going to substitute something out to change the variables. In the process, we change it into an easier problem. And when we do that, here's the chain rule. Notice when we did the derivative of the chain rule, we had a function inside of the function. And what we would do is we take the derivative of the outside function, keep the inside function inside alone, but then on the outside multiply by the derivative of that. Now when we work backwards, we're going to start with it looking like this. And it looks kind of messy because you got a function inside of a function, and outside of that function you got the derivative of the function. And when it's all said and done, you got a composite function plus c. We're going to talk about how to recognize this. And we're going to take this and use the chain rule to simplify it. So what we do is this complicated function, we recognize that this is inside, and it simplifies to this. And I will show you how, I think on the next slide. So this is the pattern you're going to look for as you do these types of problems. You're going to look for, okay, I have a function inside of a function multiplied by the derivative of the inside function. Outside function, inside function, derivative of the inside function. All right, so just look at these and notice how we can recognize that pattern. All right, so here we got x squared plus 1 inside of a fourth power. Well, what's the derivative of x squared plus 1? Well, that is 2x. So this fits that pattern. We got a composite function, a function inside of the fourth power, multiplied by that 2 times x. Here we got a function inside of a cube root, x cubed plus 1. Derivative of x cubed plus 1 is 3x squared. We have a function inside of a function, and it's actually just a set of parentheses. So it's to the first power. And then we have the derivative of tangent x plus 3 is secant squared x. Now let me show you kind of how to use it. And I'm going to introduce a concept of a third variable, or an extra variable. So we're going to do a first. All right, so my inside function, I want to kind of simplify. I'm going to take my inside function and I'm going to use another variable to represent it. We've been using u all this time, so let's keep using u. U equals x squared plus 1. Well, the derivative of u with respect to x is 2x. Now take a look. We got right here we got u. Here we got 2x. Let's substitute those in. All right. 2x is du over dx. We usually keep the differentials at the end, so I'm going to kind of rewrite this over here. This is u to the fourth, so we got u to the fourth times du dx of dx. Now, if you take a look, and you know your basic algebra, dx on top, dx on bottom, they cancel. And we got the antiderivative of u to the fourth du. That's pretty simple. That's power rule. So we're going to take our power, go up, divide, and then plus c. Now we're almost done. The reason we're not done is because our differential is x. Our answer is in u. So we take our u and plug it back in. So it's 1/5 of u, which we said was x squared plus 1, to the 5th plus c. All right. I'm actually going to stop there. It looks like we're pushing 12 minutes. I want to keep this under 15 so we can put it on YouTube in case some of you would prefer YouTube. So we're going to stop there. Why don't you try these two problems that are on this screen, and we'll start class tomorrow with those two problems.